Wormholes explained. If you've ever watched Star Trek or Marvel movies, then you might have seen a wormhole. In fiction, they're used as quick and easy shortcuts to travel vast distances across the galaxy. And while there is no evidence that these science fiction devices actually exist, physicists say that, mathematically speaking, wormholes are possible. But if they do exist, they would be more like cosmic sieves than interstellar shortcuts. Here's what we know so far about wormholes. What is a wormhole? First, let's start with the basics. What exactly is a wormhole? To answer that question, we first have to talk about space-time. Space-time is a concept in physics that combines the three dimensions of space with the dimension of time into one four-dimensional continuum. Space-time can be visualized as a kind of fabric that is affected by mass and gravity. The more mass an object has, the more it warps the space-time around it. This warping is what we perceive as gravity. Now imagine that this fabric has 2 points that are very far apart, representing 2 different places in the universe. Normally, if you wanted to get from one point to the other, you would have to travel along the surface of the fabric, which represents traveling through space. It would take a long time to get there, because you would have to cover a lot of distance. But what if there was a way to get from one point to the other more quickly by cutting through the fabric itself? That's essentially what a wormhole does. It provides a shortcut through space-time that allows you to travel from one point to another much faster than if you were to travel along the surface. In theory, a wormhole could connect 2 distant points in space or even 2 different points in time. However, the concept of time travel raises some serious paradoxes, and it's generally considered to be outside the realm of possibility based on our current understanding of physics. So for now, we'll focus on the idea of wormholes as space-time shortcuts that connect 2 points in space. How do wormholes work? The idea of wormholes was first proposed in the 1930s by physicist Albert Einstein and his friend Nathan Rosen. They were trying to find solutions to Einstein's equations of general relativity, which describe how space-time is warped by mass and gravity. One solution to these equations was a kind of tunnel that connected 2 distant points in space-time. They called it a bridge between 2 separate regions of space-time. Unfortunately, their calculations showed that the wormholes would require infinite amounts of energy to keep them open, so they were not seriously considered until later, when physicists realized that the concept could be applied to hypothetical forms of matter with negative energy density. But even with negative energy, keeping a wormhole open is no easy feat. A wormhole is essentially a black hole with something on the other side. Just like a black hole, a wormhole has an event horizon, which is the boundary around the wormhole. Once something crosses the event horizon, it cannot come back out. The difference between a wormhole and a black hole is that a wormhole has a second opening on the other side. The event horizon of a wormhole is also known as the throat, and anything that enters the throat cannot escape, not even light. Once something falls into a wormhole, it would be stretched and compressed by the intense gravity, and then it would disappear from sight forever. We wouldn't even be able to see it getting smaller and smaller as it approaches the singularity at the center of the wormhole. Instead, it would just vanish from view as if it had never existed. To prevent the wormhole from collapsing, you would need a lot of exotic matter with negative energy density, probably more than the entire mass of the visible universe. And don't think about sending a probe through a wormhole to explore the other end. When an object passes through a wormhole, it doesn't just go to the other side, it actually gets duplicated. Anything entering a wormhole would be split into 2 halves, with one half remaining in our universe, and the other half ending up on the other side. What would a wormhole look like? If wormholes did exist, they would look like giant tunnels of swirling energy connecting 2 distant points in space. At the center of each wormhole would be a bright, glowing event horizon that would appear to be a bottomless pit of darkness. As you approach the event horizon, the gravity would become stronger and stronger until it was thousands or even millions times greater than the Earth's gravity. If you were to cross the event horizon, you would be pulled into the wormhole and disappear from view. Could we travel through a wormhole? While wormholes are theoretically possible, it's highly unlikely that humans will ever be able to travel through one. Even if we were somehow able to create a wormhole, it would be extremely dangerous. The immense gravity at the event horizon would likely tear apart any spacecraft that attempted to cross it. And once inside the wormhole, anything would be at the mercy of the intense forces that would be generated as it was pulled towards the singularity. Furthermore, the energy required to create and maintain a wormhole would be enormous, far beyond what we are currently capable of producing. Finally, the matter with negative energy density that would be needed to keep a wormhole open is purely hypothetical and has never been detected. Would a wormhole be a time machine? One of the most fascinating aspects of wormholes is the possibility that they could be used as time machines. If a wormhole connected two different points in time, it would allow for the possibility of time travel. However, this idea is fraught with paradoxes and is generally considered to be impossible. According to Einstein's theory of general relativity, time is interwoven with the three dimensions of space into a four-dimensional continuum known as space-time. This means that events that happen in space are also linked to events that happen in time. If you were to create a wormhole that connected two different points in time, it would create all sorts of paradoxes. For example, if you were to send a message back in time via a wormhole, it could potentially create a situation where the message would arrive before it was sent. This violates the fundamental principle of causality, which states that cause must come before effect. There is, however, a theoretical possibility that wormholes could be used to create a closed time-like curve, which is a path in space-time that loops back on itself. If such a path were created, it could theoretically allow for time travel. However, this would require the existence of exotic matter with negative energy density, which has never been observed. Even if negative energy did exist, it's unclear whether it could be used to create a closed time-like curve. And if it were possible to create a closed time-like curve, it's unclear whether time travel would be possible. There are also numerous paradoxes associated with time travel, such as the grandfather paradox, which poses the question, what happens if you go back in time and kill your grandfather before your father was born? These paradoxes suggest that time travel may not be possible, as it could lead to situations that are logically impossible. Are wormholes real? Despite the fact that wormholes are a staple of science fiction, there is no evidence that they exist in reality. In fact, most physicists agree that they are highly unlikely to exist. The main reason for this is that wormholes would require the existence of exotic matter with negative energy density, which has never been observed. Additionally, the very nature of wormholes creates significant paradoxes, particularly when it comes to time travel. Despite the lack of evidence, some people believe that wormholes could exist. There are several theories that propose various methods of creating wormholes, but none of these theories have been proven, and many of them remain highly speculative. Conclusion: wormholes are fascinating concepts that have captured the imagination of scientists and science fiction fans alike. While there is no evidence that they exist in reality, the idea of being able to travel vast distances in space, and possibly even through time, is incredibly appealing. Mathematically speaking, wormholes are possible, but they would require the existence of exotic matter with negative energy density, which has never been observed. Additionally, wormholes create significant paradoxes, particularly when it comes to time travel. Despite the lack of evidence, the concept of wormholes continues to fascinate and inspire scientists to explore the possibilities of this phenomenon. Who knows? Maybe one day we will discover that wormholes are real and that they hold the key to unlocking the mysteries of the universe. Or maybe they'll just turn out to be a big cosmic sieve. I hope you enjoyed this episode, with a special thanks to my supporters.